Disclaimer: please note that the following video showcases Golems, a free 3D sandbox physics simulator. However, I am neither the owner of the game nor affiliated with it. This video is for entertainment and informational purposes only. Have fun watching the content. Hi, my name is Adam. Today, I'm showing off a game that I have been playing for quite some time now, and I want to show you how to play it. This game is called Golems. This game is not your typical PC game, in which you don't have a preset goal or objective. Instead, this game lets you play around with mechanical and electrical components to create simple or complex machines. In this video, I'm going to show you how to navigate Golems so that you can learn how to get started in creating your machines. The first thing you'll see when starting the game is a gray-colored platform. This platform will always appear when you start the game. The platform is the surface that you will be able to start building your machines. On the left side of the screen, you can see a side menu. The menu has all of the objects and components that you can use to create your machines. I am going to, first, show you how to change the camera perspective, so that you are able to navigate around your creations, so that you can get a better look at them when you are building them. To change the camera perspective, you first right-click on the screen and drag your cursor to the right. Doing this will cause your camera perspective to orbit around a center point of the gray platform. Next, left-click on the screen and drag your cursor to the right. Doing this will cause the camera perspective to move across the gray platform. The camera will be now at a different orbiting point location than at the start of the game. Another thing to learn is that the game has a default location from where the camera perspective will start. The default location is at the center of the gray platform. Finally, you can also change the distance that the camera is orbiting at. To do this, simply scroll down the scroll wheel. This will cause the camera perspective to change by moving closer to the orbiting center point. Lastly, move the scroll wheel up. This will move the camera away from the orbiting point. If you find yourself in an undesired position, you can press the F key on your keyboard. This will bring your camera perspective back to the center of the gray platform. Now that you have been shown how to move the camera perspective, the next thing to do is to bring up an object for you to manipulate. First, go to the left menu. Then, select the blue button that has a box. This will spawn a three-dimensional cube that will appear in the center of the gray platform. Now, before you start building anything, you should see for yourself what the green play button at the top right corner of the screen does. The green play button will start simulating the physics of the game. You can manipulate the box by moving your cursor over onto the box and left-clicking and holding the left-click button. Doing this will give you the ability to move the box with your mouse while the game is simulating in real time. The green button is now a pause button. When you press the green Start Simulating button, there will appear two new sets of buttons. The green button is now a pause button. The second red button is to completely stop the simulation. One neat trick that you can do is you can throw an object through the air and then quickly press the green button again, which this will pause the simulation. Pausing the simulation is essentially pausing time, which gives you the ability to move the camera perspective in the building area of the game so that you can see the objects that are being simulated at different vantage points. If you want to focus your current perspective to a specific part of your machine, you simply first have the object that you want to focus on selected. Then just press the F key on your keyboard. This will move your perspective to the object that is currently selected. Now that you have seen what Golems can simulate, now we can start to learn how to start building things in Golems. Now, continuing with the box that you have spawned up, you can now select the box. This will highlight the box to a green color. When an object is green, it means that you are currently selected the object to be manipulated. When the object that you have selected is green, you can change certain aspects of the object. Like, you can change the height dimension of the box by holding down the Alt key. This will appear white spheres at the faces of the object. These spheres can be clicked on and dragged to extend or reduce the length of the object. Next, you can move the selected object position by left-clicking the object. When you click on the object to be moved, you'll notice that there will appear a white disk with black circles that is in the center of the object. This disk is an indicator to show you of what plane of movement that you are currently in to move the object. You can change the plane of movement by holding down either the Z key or the X key, like how I am demonstrating here. If you want to rotate the object on a certain plane, then you'll need to hold down Shift key while holding left click and moving the cursor to the direction that you want your object to rotate. You can change what plane of rotation of the object by holding down the Z key or the X key while holding down Shift key. Now that you have learned how to manipulate objects in the game, you can now spawn up the next objects to manipulate. Now, you might be wondering, how do you build machines? Using objects like a box? The trick is to fuse two objects together so that they can act like one solid structure. To do this is quite simple. First, you take an object like a box and then spawn up another box. Then, you simply need to move the objects together until they physically touch. If you have two or more objects touching each other, then they will automatically be fused together, acting like one solid structure. The object that I've been using to demonstrate the manipulation of is of 1 out of 8 blue button objects that are stiff, solid objects that act like the basic building blocks for creating machines. The blue button objects are as follows: box, sphere, cylinder, tube, pyramid, cone, ellipsoid, and finally, capsule. One last thing to help you with building your machines is the ability to multi-select multiple objects at once by simply holding down the Control key and holding down left click and dragging the cursor so that there will appear a green multi-select box. Doing this allows you to select multiple objects at the same time. You also can select specific objects to move just by holding down the Control key. This will give you the ability to select certain objects to be manipulated. One last thing that can help you to manipulate a group of objects is the ability to select one object that is making contact with other objects. You can select all of the parts of a machine all at once, if all of the parts of the machine are physically connected to one another. You can do this just by selecting the button that is in the left menu that is labeled as Island Select. If you have this button selected, you'll be able to move an entire machine all at once, just by selecting one part of your machine with just one click of the mouse. Now, for the next group of components, the red button objects, we can consider them as being different forms of what are called actuators. Each one of these actuators can perform a specific form of movement. The first actuator is called axle. This actuator is a rotational component that allows you to make parts of your machine spin. Axles will give you the ability to make machines that have spinning parts. Like for example, you can arrange 4 of these axles onto a square-shaped object to create a simple car. This actuator is called hydraulic. A hydraulic is an actuator that can extend and retract, traveling in a straight line. If you are making a machine that requires the machine to travel in a straight path, then hydraulics is a way to achieve this. The next actuator is called hinge. A hinge is a partially rotating component that can rotate from 0 to 180 degrees. This is a useful component for certain applications. For example, you can use a hinge to make a door to a structure, like a car. The last red button component is called ball and socket. A ball and socket is like a hinge, except instead of rotating on a single axis, this can rotate on all 3 axes. The ball and socket component is the only red button component that cannot be driven or powered. Instead, it is completely passive. Now that we have gone over the red button objects, we will now look at the green button objects. The green button objects are objects that perform a function that isn't mechanical. Instead, they are objects that either outputs a value or reads a value output. There are 8 green button objects in the left menu. 3 of these components are similar to the blue button objects. They have a physical form. Either they are a pyramid, a box, or a sphere. But the rest of the green button objects can only exist in a different building mode of the game, called wired mode. I will explain what wire mode is later in this video, after I go through the items that are in the left menu. The first object that you should select is called touch sensor. A touch sensor is a component that looks like a box, but this component is able to do a function. The touch sensor is able to output a value when an object is in contact with the touch sensor. The next component is called multimeter. This component looks like a box as well, but this component has a different function. A multimeter is a component that has 3 different functions that can be used to measure or control an object, velocity, position, and acceleration. The next component in the green button objects group is called distance sensor. A distance sensor is an item in the green button group that looks like a pyramid. This object may seem like it appears to not have a function until you have the object selected. Then you'll see a red-colored pyramid shape appear in front of the gray pyramid. The red pyramid is a non-physical object in which it cannot interact with any other object, meaning the red pyramid can pass through things without it colliding or interacting with objects while the simulation is running. This component can be linked up to something so that whatever passes through the red area, it will cause an output value, in which you are able to control a machine component, like an axle or hydraulic. You can change the shape of the red pyramid by going into the Properties window. The pyramid can change to either to be a cube or sphere, or cylinder. Finally, the last green button component is called contacts. Contacts looks like spheres that perform a function. If you arrange a few contacts in a line, you will be able to pass a value in between them. Contacts are similar to touch sensors, in which they can output a value if a contact is physically touching another contact. You may have noticed that I haven't mentioned what were the other green button components and what they do. Don't worry. I will explain what they are and go through them later, when I show you how to build in wire mode. The last group of components are the yellow button objects group. The first yellow button component is called rocket. Rocket is a component that looks like a cylinder, and its name is exactly as it implies. It is a component that can propel itself in a direction that is opposite of the flaming end. This component gives you the ability to create machines that can either hover or fly at great speeds and great distances. The next component is called gear. A gear is like a wheel that has teeth around its parameter. A gear can mesh with another gear to give you the ability to create machines that can output a high torque or a low torque but high speed rotation output. The next component is quite similar to a gear, except this component is a straight or flat version of a gear called rack gear. This component can mesh with gears to transform a rotation motion to a linear motion. This next component might sound like it came straight from some science fiction film, but it is a component that can output a force in a straight direction. This component is called force beam. A force beam is an object that looks like a capsule, except this capsule emits a beam that produces a force that can push objects in the direction to where the beam is pointing. The last thing to learn about the physical objects of the game is that each object has a properties window that lets you be able to change certain characteristics of the object. If you select an object, like a box, then click the Enter key on your keyboard, you'll see a window that is labeled as Properties. The Properties window gives you the ability to change the physical characteristics of the selected object. The first thing that you'll notice is the Tab button labeled as Matter. When you are in the Matter tab settings, you'll see a setting that is labeled as Density. The density is the weight value of the object and its material name that corresponds to that material. If you select the material setting, you'll see a list of materials that you are able to choose from. Each material has its own unique weight value. You can change the density value to a number that ranges from 0.001 to 100.00. 100.00 is the limit to how dense you can make an object. The next thing you'll see is a checkbox setting labeled as Make this object static. This will make a object fixed to its current position in 3D space so that you are able to make parts of machines to be anchored to specific locations in three-dimensional space. The next checkbox setting is labeled as Make this object sticky. This setting gives the object the ability to stick to other objects in the game. Here, I am demonstrating the sticky nature of an object that is set to stick within its settings. Now that I have showed you all of the physical objects that you can spawn up in the build mode part of the game, there are a few components that I purposely excluded until now. Now, I'm going to show you a different part of the game. This game has a different mode, which is called Wired Mode. Wire Mode is a building mode that makes the appearance of the game turn into a engineering blueprint color. When you are in this mode, you are able to spawn up certain components that only can be seen in Wire Mode. The components that you are able to see in Wire Mode are as follows: battery, function, input, oscilloscope, finally, camera. When you are in Wire Mode, objects that you have spawned up in the building mode of the game will become a shade of blue, in which you will be unable to interact with. But there are some components that will have what appears to be handles or bars that are within the components. We can consider these bars as the positive and the negative terminals of the components. These terminals are colored green and yellow. Just like batteries in real life, these terminals can only be connected to the other color terminal. For example, a green terminal can only be connected to a yellow terminal, and vice versa. Two terminals of the same color cannot be connected to each other. Some other components might have an extra green terminal, which makes it possible to connect an input from another component. To connect a component in the wire mode of the game, you simply place your cursor onto the terminal that you want to connect with, and left-click and drag to the terminal you want to connect to. Doing so will appear a yellow-colored wire. You can also change the polarity of the yellow wire. Changing the polarity of a wire will give you the ability to change the output of a value of a component from a positive to a negative by holding down the Alt key. Doing this, you will change the color of the wire to the color red, keeping in mind that you are only able to connect a terminal to another terminal only if they are not the same color. Now that I have explained how to connect components in the wire mode of the game, I am now going to show you what each of these components can do. The first component is called battery. A battery is a component that outputs either a constant value or a non-constant value. Unlike a real battery, the terminals are not exactly in the same position as real batteries are. Instead, the green terminal is the input. The input is the green terminal located on the side of the battery that you are able to attach an input from a source. I will also mention that these components' physical size cannot be changed. These components are only able to be moved and rotated. The battery, if selected, and pressing the Enter key, will bring up the Properties window. The Properties window contains 4 tabs. These tabs are as follows: Function, Battery Options, Position, and finally, Appearance. Let's look at the Function tab of a battery. The Function tab, if selected, will display a graph. This graph represents something that is called a time signature. As you can see, the graph is represented as a 4-quadrant graph. The blue part of the graph represents what value is currently at through this time signature. The graph of a battery will always be, by default, set to 100%. This is the time signature. That starts at the top left corner of the graph. Then, the graph ends at the top right corner of the graph. What this graph is showing is that the battery will output a constant value of 100%. But there are different preset time signatures that you can pick from by pressing down the drop-down menu right above the graph. When you click on this setting, you'll see a list of different preset time signatures. You can select each one to see what different outputs they produce. Now, for the next component for you to select is called oscilloscope. A oscilloscope is a component that is very useful to help you see what the current output of a component is. You are able to attach this component to the outputs of other components to see, in real time, the output values of other components. The next component is called function. Functions are components that can receive an input value and have the output of value to either to be smaller or larger or unchanged. For example, if you put in a value of 1.0 into the input of the function component, then the output will still be 1.0 unless you change the function line graph that would change the output value. either greater or lower. Here is an example. I have attached a battery that is outputting a constant value of 1.0. Then, I have it attached to the input terminal of a function. Finally, I have attached the output terminal of the function component to an oscilloscope. The oscilloscope will display the current output value of the function. If you want to see the current value of a component, then an oscilloscope is the way to achieve this. You first need to spawn up an oscilloscope, then select the oscilloscope and enter into the Properties window. You will see an option to change how the oscilloscope will be displayed. Select the Text option in the drop-down menu. This will display a window during the simulation. The window will display a simple decimal number that displays a number starting at 0.0, then reaching up to 1.0. After doing this, you should then go into the Properties window of the function component. You will see a graph that looks similar to a battery graph. But the graph of a function component is not the same as a battery graph. The battery graph is set up to have time as its function along the red axis. The graph that is in the function component does not have time as its function. Instead, the function graph is displaying the amount of a value of its own input to its own output. Here is a way to make the function to be able to output a lower output than its own input. You first go into the Properties window of the function component. Then, you can physically change the graph slope angle by right-clicking and dragging your cursor over the gray bars that are located on the sides of the graph. Doing this, you will notice that the graph slope or angle will change. If you want the value to be smaller than the input value, you simply need to adjust the slope to be slightly less steep. Doing this will cause whatever input value that the function component is receiving to reduce to a smaller value. Finally, the last component that I'm going to show you is called input. A input appears to be a gray box that has a yellow terminal sticking out of one side. This component will give you the ability to make specific keys on your keyboard to be connected to your machines so that you are able to either activate or control your mechanical or digital creations. To set up an input, you simply need to spawn up an input. Then, go into the Properties window of the input component. You will see a setting where you can change to a specific key to be binded with. You just need to select the setting that is labeled as key. Then, you can change the key's setting to whatever key you want, just by pressing the specific key on your keyboard. Finally, one last thing to learn to help you build your machines is the ability to move objects or components at a fixed interval so that you can make things more precisely and accurately. To do this, all you need to do is to select the small gray circle that is located at the bottom right corner of your screen that is labeled Snap. After you enable this feature, you will notice when you move an object, the object will snap at a fixed interval distance along its plane of movement. This is a very useful feature that helps you to build your machines that require a certain placement of a component or object of a machine. This feature also affects how you rotate objects and components. When you are rotating an object or component, the object will rotate at certain fixed angles. The snap feature can be changed to your liking within the game's home menu. To get to the game's home menu, you simply press the Escape key on your keyboard. This will bring up the game menu settings where you can find a few buttons. Select the button that is labeled as Environment. The Environment settings is where you can change certain settings of the game environment. One of these settings that you can change is labeled as gravity. In this setting, you can change the gravitational acceleration of the environment to either to be weaker or stronger, or even at a different direction. Right below the gravity setting is the grid spacing numbers. You can change these numbers to whatever interval that you desire. The last setting that is below the grid spacing setting is the angle degrees number. You can change this number to whatever degrees you want. Finally, the very last component of the yellow button group is called camera. Camera is a component that gives you the ability to see your machines from a specific point of view or even have a third-person perspective of your machines. This component is simple to use. You just need to click on the camera button in the left menu. Then, you can either place the camera within the space of the build area at a fixed position, or you can place the camera directly onto your machines. You can even have the camera to be hooked up to an input, either from an input box or to a sensor. Finally, after you are done building a machine, you can save your machine just by going into the Game menu and selecting the Main button and selecting the Save Machine button. When you select this button, a window will appear where you can give a name to your machine that you want to save. After you saving your machine, you are able to load your machine back into the game or even import your machine into your current machine by either clicking the Load Machine button or importing the machine by clicking the Import Machine button. Alright, I think that is enough. I think that I have explained how to play this game. This video is getting a bit long for my liking. I have probably skipped a few things within this video, but I think I have gone over the majority of the features and mechanics of this game. I wanted to make this showcasing video to first introduce to you to the game, so you can get the idea of how the game works. I am planning on uploading more videos of what creations that I have been making in Golems. If you have made it this far into this video, then thank you for watching. I've hoped you enjoy this video. If you like this video, then leave a like. If you don't like this video, then I'm sorry for boring you. If you want me to show more of this game in future videos, then maybe you could hit the subscribe button to get notified about new uploads. Goodbye.